There are some special cases where we get something odd happening with either we're going to get x can be anything you want it to be, or there's no solution. So here's a case of no solution. X plus 3, let's say, is equal to x plus 5. Looks pretty innocent, looks like a normal equation. But when you try to collect the x, if you subtract both sides by x, right, you get 3 is equal to 5, which is completely false, right? So even in this original equation, because these two are exactly the same value, no matter what you plug in here, they're going to cancel out, and we're going to get the statement 3 is equal to 5. When such thing happens, there's no solution. Okay, there's no x value that will work in this equation. Here's an example where x can be anything it wants to be. 2 over 3x is equal to minus 5 over 4x. Okay, this is going to have infinite solution. Okay, so let's try to collect the x by multiplying both sides by 12. Okay, so multiply both sides by 12. And then you get 4 times 2x minus 5x times by 3. So you get 8x minus 15x. Okay, if you bring that right to the other side by adding 15x to both sides, we get 23x is equal to 0. And then clearly here, actually x is equal to 0. Sorry, this is not a case of infinite solution. It just has a solution. Okay, solution. And where x is equal to 0. Okay, so here's the one with infinite solution. Okay, so let's say I had x plus 2 is equal to 3x plus 6 over 3. Again, it looks like a normal equation, but how can we tell? So let's do some work to simplify this. We can't really easily tell from here. Let's multiply both sides by 3 to eliminate this fraction. Right? So you have 3 times by x plus 2 is equal to 3x plus 6. Okay? And then let's eliminate this 3 by dividing both sides by 3. Actually, that'll actually take us back to here. Okay. So, I mean, this is a legit step, but I guess we could have just divided this and this by 3 here. Okay, so then look what happens if we do that. 3x over 3 plus 6 over 3. We get x plus 2, or this simplifies to x plus 2. But that's equal to exactly what we have on the left side. So we actually get this x plus 2 is equal to x plus 2. In such a case, we can plug in any x value we want in either side, and the equation will always be true. So you can plug in anything you want in x. So we say x belongs to the set of real number. This means just x can be anything it wants to be. Also, right, from here, if you know a simple distribution, you could have done this. We get 3x plus 6, 3x plus 6. Maybe even, I mean, right here, you can see it's exactly the same, but you can subtract both sides by 6 to get 3x equals 3x, and you get x is equal to x, right? Which is always true. So from here, you can conclude that x belongs to all real values as well.